Good morning, Algebra 1 students. Today we start a new unit, and the name of the unit is Systems of Linear Equations. So you probably want to write that down. It's Systems of Linear Equations. Okay, so this is lesson number 1. So make sure this is in your notes. So here we have two equations. This was called a system of linear equations. Systems of equations means more than one equation. Systems of linear equations is more than one equations. So what does it mean to solve this system? Very simply, it means to find all the points of intersections of these two lines. In general, there are three distinct possibilities that you will find. First, the two lines will intersect at a single point, and the x and y values of that point is the solution to the system. In other words, for this one, the solution would be this point, this x, y, and it will appear as an ordered pair. For example number 2, the two lines will never intersect, so there is no solution because the lines are parallel and they will never intersect. So you're looking for the point of intersection. And the third one is the two lines are directly on top of each other, resulting in an infinite number of intersection points. The two lines are basically the same. And that's what you're looking for when you solve a system of linear inequations. So how can we tell, just by looking at the equations of two lines, which of the three pictures above represents their orientation? And these are three things that you'll need to have in your notes and to memorize. If the slopes of the two lines are different, then it's the left picture above, and we will have only one point of intersection. That's if the slope of the two lines are different. If the slopes are the same and the y-intercepts are different, then they will be parallel points and you will have no points of intersection. That's if the slopes are the same, y-intercepts are different, they are parallel, no solution. If the slopes are the same and the y-intercepts are the same, so both are the same, then they are actually the same line. So it'll be this one. The two lines will be on top of each other, and the answer is infinitely many points of intersection because they are the same line. So let's look at some examples. I believe there are 5 examples. All right, in each example below, you want to examine the slope and the y-intercept and then tell how many points are in the solution set of the system and make a rough sketch of the lines. So for the first one, you see we have y equals x minus 1. So I know that my slope is 1 and my y-intercept is negative 1. So you're comparing the slope and the y-intercept on these. So the next one, we want to solve for y. So the easiest thing I can do is subtract 9 from both sides, because here's my y on the right, and then I will have y equals negative 4x minus 9. I can rewrite that so that it looks more like the y slope-intercept form of a line. And I know that my slope is negative 4 and my y-intercept is negative 9. So because the slopes are different, then I know that I will have one line that is basically going up, right? That's the y equals x minus 1. The other one has a slope that would be going down pretty steeply. So that would be the other one because you have a negative 4x minus 9. So we would have one point of intersection wherever that is, and you don't have to find the exact point at this time. All right, example number 2. We're going to again look for the slope and look for the y-intercept. So y equals x minus 1, write that down. You know you have a slope that equals 1, and then we have a y-intercept that equals negative 1. For the problem here, we're going to solve for y. So that means I'm going to add x to both sides here. So I would get y equals x plus 7. If I look at this, I see that my slope is also 1, so they have the same slope. but my y-intercept is going to be 7. So I have a different y-intercept. So because the slopes are the same and they have a different y-intercept, that means they will be parallel lines. They both have a positive slope, so they would look kind of like that. And there is no solution to that. There is no solution because there is no intersection. The lines will never intersect. All right, let's look at another example. Okay, so write down this example into your notes. Then you want to solve for y, and you want to compare the slope and the y-intercept. So the first one, I'm going to add x to both sides, and I end up with y equals x plus 2. What is my slope? My slope is 1, and my y-intercept is 2. Let's go to the second problem, and I'm going to solve for y. So first I'm going to subtract 6 from both sides, and so I get 3x minus 3y equals negative 6. Then I'm going to subtract 3x from both sides. Remember, I'm trying to solve for y, so I would get negative 3y equals negative 3x minus 6. Then I divide by negative 3, and I would get y equals positive 1x plus 2. Well, notice that I have it's the same exact equation. Y equals x plus 2. My slope is the same. My slope is 1, and my y-intercept is the same. So when they are both the same, that means you have the same line. So how many solutions do you have? You have an infinite number of solutions. Infinite number of solutions. Okay, we have another section to this lesson, so let's keep going. Okay, so a point xy can be proven to be a solution to a system of two linear equations if it satisfies both equations. What that means is that when the point xy is substituted into both equations, they are both still true. So it says, example 4, prove that 1, negative 2 is a solution to that system. So all we have to do is substitute the x, which is 1, and the y, which is negative 2, into these equations. So I'm going to do 3 times 1 plus a negative 2 and see if that is 1. 3 plus negative 2, is that 1? Yes, it is 1. So it is a solution to the first equation. So let's see if it is a solution to the second equation. So we're going to substitute the 1 for x minus a negative 2 equals 4. So this is 2 minus a negative 2 would be plus 2. So yes, we see that it is equal to 4. So that one checks. So this is a solution to both equations, or a solution to the system. And that will mean that these two lines will intersect at that point. One more example. Okay, so now we're going to do the same thing, and we're going to determine if this point is a solution to the system. So I'm just going to substitute the x and the y into the system. Negative 3 plus 1 equals negative 2. Well, that is true. So in the first one, that point would be on that line, or it satisfies that equation. Now I'm going to do the next one. 3 times negative 3 minus 2 times 1, is that equal to 1? Well, 3 times negative 3 is negative 9, minus 2, does that equal 1? Well, no, that's negative 11, and it does not equal 1, so this one does not check. So is negative 3, 1 a solution to the system? No. This number, negative 3, 1, lies on the line, that line, but does not lie on this line. Okay, so that's it. Now you have your homework assignment, which I will give to you, and I hope you have a great day.